Hi all, we're going to get started in just 10 seconds. Welcome back to the J Champion Conference. To kick things off, we have a quick note from Oracle.
Good morning. I'm Jennifer Nicholson with Oracle, and I want to welcome you to the J Champions Conference, which is organized by Java Champions with all Java Champion speakers. Over 4 days of sessions on January 13th and 14th, and 18th and 19th, you will hear from 28 different Java Champions. So who are these Java Champions? Well, they are a select group of over 300 technical luminaries who are leaders in the Java community. You can find a list of Java Champions and learn more about the award at developer.oracle.com/Java Champions. So thank you for being a part of the first J Champions Conference and for your partnership in making Java the #1 programming language and development platform in the world as we continue to celebrate its 25th anniversary. Now grab your favorite beverage, get comfortable, and enjoy one or all of these 24 different informative sessions. Thank you.
Thanks. Now we can kick things off with our first session of the day. We have 2 speakers today. Rafael del Nero is a Brazilian developer and the creator of the No Bugs project. Paul Weber is the head of the San Diego user group, where it's always warm and sunny, and I'm sure we wish we all would be. Today, they're going to be presenting Duke Star Trek with Java 15 code challenges. I'm told that it's interactive, so I look forward to seeing how it goes. Take it away, guys.
Thanks, Jean.
Yes, thank you very much, Jean. So as she introduced, I'm Paul Weber out in San Diego, and my friend Rafael, where are you at today?
Hello, everyone. I am in Brazil today, in a warm day.
Yeah. So we hope everybody finds this session very informative and challenging, and we'll go ahead and get going with our first fun slide here. So our useful information and fun. So all this code stuff is up on GitHub. Rafael's got his little area up there. It also can run on Oracle Cloud if you so desire. It is Java, of course. Now, caveat here, the formatting you're going to see on the slides is not appropriate formatting for your code. The GitHub has that appropriate formatting, of course, but the slides we had to condense so that we could try to do all this stuff so you could see it. And you may have some eye challenges out there, so get ready to zoom in. We'd also like to state that the planets that were mentioned in this slide are not harmed in any way as we made this presentation. So as Java and Duke go on their mission here, we have a few planets of JDKs to visit. This is our mission outline, 11 challenges that we'll be going through, and they will be very interesting and challenging, of course. Also, if you need to contact either Rafael or myself, our Twitter hash codes are here, and I'm at the SD Jug, and then the personal one is Captain Weber. So why don't we go ahead and get started? Let's warp out to our first historical destination. So here we are, JDK solar system, circa 1996 to 2009, where many planets were absorbed by the big red giant. Lately, though, we have a more interesting solar system with a couple of stable planets and hyperbolic planets going through. We're going to go through and visit each one of these. So our first one is JDK6, which apparently has already been absorbed by the big red giant. So with that, I'm going to turn it over to Rafael with our first challenge.
Awesome. Thanks a lot for the amazing introduction, Paul. And let's get started with our first Java challenge. So as you can see, we are using the deck interface here. and we are using a couple of methods, and then we are printing some information from this deck interface. I'm gonna give you some time to think about the answer, and let's see now. What are the alternatives?
So some pressurized music here, waiting for you to understand what is the cue doing. Oh, by the way, we should probably mention to people to go ahead and write your answers in the comment section.
Exactly. Yeah, very well said, Paul. So if you know the answer, just write down on the YouTube chat so that we can know if you are ready to answer to this challenge.
So are we ready for Duke?
Well, let's see. Let's see the answer then. Okay, I see one answer.
One
B.
answer. Okay.
Okay. Okay, guys, I will explain why it's this answer. So, as we can see, we are adding first wharf, but then we are using the method push, which adds the element on the top. So Odo would be at first, and wharf would be in the second position, and then we are gonna invoke the add last method that we're gonna add the element on the bottom of the stack, right? Therefore, it's gonna be Odo, wharf, and Scott. And on the bottom, we are using the remove method, which will remove the element on the top, and it will show it. And the remove method will also throw an exception if the deck is empty. The pick method will only return the element from the top. It won't remove anything. And the pop method will also remove the element on the top, and it will show it. And if the deck is null, we're gonna throw an exception. And in the pull method, it does the same thing. It will remove the first element and show it, and it doesn't throw an exception. So that's pretty much it of this challenge. About this challenge.
Very cool. That's remove peak pop pole, if you can say that 3 times fast.
Exactly. Yeah.
All right, let's warp out to the next planet, JDK7, which has also been absorbed. And in this one, we seem to be having a couple door malfunctions here. So let's see if we can get auto closable to work for us. We're taking a look at this, very simple. We have a open method, we have a close method, and then we have our main method to take a look. So let's cue the music, and the doors are opening for your challenges. Please write them into the chat channel what you think is the solution set. At least we know we have one listener out there from the last slide.
Exactly. Guys, interact with us.
It's more fun, even if you guess.
Exactly.
Or maybe they just enjoy the music. Okay, so let's go ahead and see what Duke likes to show us here. Flying around in his jetpack. Okay, C. Okay, so ship door is closed. We can see in number 1. Number 1, sorry, we open the door, and then we go up to the top line 2 there, where we're going to throw a runtime exception but because we're auto-closable, line 6 gets executed, so we actually print out ship door is closed. Then we move on down to we capture the exception, and then we do our finally, which is the end. So auto-closable allows for these resources to be freezed via that close method. So it's pretty nice. Kind of a little bit better thing on the finally that we just threw in there, because finally still works also. Okay, let's go ahead. We got a couple of choices there in the chat channel. Great. Thank you. We'll try to see those and talk about them beforehand. Let's fly off to the next planet, JDK8, which is a long-term support orbit, a nice stable orbit for us. Over to Rafael.
That's it. Thanks a lot, Paul. Okay, so this challenge is about streams. And as we can see, we have Lambda in the pick method from the stream. And I'm going to give you some time to think about this challenge. And then we can see the answer. Maybe you can see it now. Let's see the answers.
Kind of transporting those panels open here. And yeah, I think we should let the moderator play. What do you think, Rafael? Pressure's on. Okay, we got A's coming in. We got a B.
Okay, we have an A from Giuseppe.
Yeah. Okay.
We have A from Lampros.
Uh-oh,
Okay.
and a D, not B.
Okay.
Cool. Are you ready?
Here, ready to see the answer. Let's see that.
Flying Duke, where's he going?
Oh, it's A.
All right, we got a few A's out there. Go ahead.
Okay, so let's see why then. So there are two core concepts here with the streams. So we have the intermediate operations methods, which are methods that will program the stream. So they won't do anything unless we have a terminal operation method. So I can give you an example about the terminal operation methods. They are methods that do some kind of action. So they are the trigger of a stream. So for example, the for each method is a terminal operation method. There is also the collect method that is a terminal operation method. And if we use those methods on the streams, then the stream will do something. All right. And once we invoke the terminal operation method, then only then the peak and the limit methods will be invoked, which means that firstly, the peak method will be invoked, and then we're going to print the element on the for each method, and then we're going to do the same. So basically, it's going to go to the second element, it's going to print Spock peak, and finally Spock. So we have to remember that streams are lazy, which means that if we program the stream to limit for only 2 elements, the JVM won't go through all the elements. So it's gonna go only through 2 elements, which will make the performance more optimized. So intermediate operation methods, terminal operation methods, and remember that streams are lazy for optimization and performance. And this is it.
Okay, very good. That is very interesting, especially with Kirk and Spock peeking around the doors. All right. Doors again. So speaking of doors, what do we have here? We have a lambda within a for each loop. So this one, only a few lines of code. Let's take a look at our solution set as your tissue computers do compilation and runtime. So interestingly enough, if you were at the beginning of our session, you got the GitHub repo. How many people are quick enough to clone, load into IntelliJ, compile, run? But of course, it's more fun if you just look at it, read it. Does it work? Okay, here we go. We have a C in there, it looks like. Okay, anyone else? Give them a little count here. Okay, now there's a few more. That's Duke right away. Dun, dun, dun.
Okay.
Yeah, look at
You guys
that.
are sharp today.
Excellent. It must not be too early in the morning around the rest of the world. It is just after 6 a.m. here in San Diego. But as you can see, yes, we have a variable defined, int door number 0 equals 0. And then we're incrementing that variable inside the Lambda function, which is not right. So compiler will actually catch that for us now, which is great. So inside it needs to be final or effectively final. In other words, if we took the plus plus away, this would actually compile. So in other words, when you're using these variables inside or outside the Lambda, they can't be changed if they're inside the Lambda. I was just reading yesterday too about this. If you made the variable static, so its scope is static, this would actually work, which is very intriguing. So another interesting thing there. Let's move on. Where are we off to today? Oh, look at this. We're heading out to JDK 9. What happened in JDK 9?
Let's see. So in the JDK 9, we have the big change of modules. And as we can see here, we have the project structure. We have Risa and Vulkan. And you can see that one module requires the other. We have also the exports from one package from the other module. Okay, so take an extra attention at this slide, because we're gonna need this information, the information from this slide, from the challenge. Okay, so just yeah, okay, let's go. So here we have the class executor from the module Risa. And we are invoking some methods from the Spock class created in the module Vulkan. And as you can see, we have two methods. We have the attack method and the method, okay? So I'm gonna give you some time to think about this challenge, and let's see the answers.
Yeah. Uh-oh. Red alert. What could be going on with this attack? But you're right. This is one of our more complicated slides. You have two slides to think about.
Yeah.
And what's this dough in there? How did the Simpsons get into a Star Trek conundrum? Well, a few people are out there thinking. Yes, we know you're thinking. We can see it.
Okay, guys. Can I see an answer in the chat? Do you want to try it out? A?
We have an A answer.
Okay. Who
All
else
right.
gonna risk?
Nothing to worry about. Okay, you ready?
Okay, let's see the answer then.
Let's see what Duke says. Zipping around, and he's going for C.
Ooh, so it's C. Okay, so there are very important concepts here. So we are trying to break encapsulation by using the attack method in the Spock class. And this is one great benefit from modules, because with modules, we can really use encapsulation. So unless we don't open the package to the other module, we can't break encapsulation and use the set accessible method. But as you can see, we can invoke the dump method without any problem. But we can't break encapsulation with reflections in the attack private method. Okay, so let's go to the next slide. Yes, there's no opens clause in the Vulkan module. But if we added the opens clause, then we could break encapsulation and we could access the private method. So to summarize here, the greatest benefits from using modules is that we can really use encapsulation. This means that we can't use the set accessible method to invoke private methods unless we use the opens clause. Then we can do that. Another great benefit from modules is that it enables us to create lightweight applications, and this is particularly very useful to create mobile apps, or even to enterprise applications in Java. There are many libraries that we don't use in Java, and they don't need to be imported, right? So we can create lightweight applications, and we use encapsulation as well. Okay, that's it.
All right, thank you, Ralph. That was a really interesting one, and JDK9 seemed to be an inflection point on our whole journey here, because there are a lot of people are still in JDK 8 land. Okay, what happened to 10? 10, oh my goodness, blown up, and some of its stuff has moved off to 11. So let's pop over to 11, which is also long-term support orbit, so stability.
Awesome.
Yes. And in this challenge, instead of having two slides, we've got the eye test. So let's take a look at this. If you can zoom in, it's very interesting. This var turnabout intruder var, basically local variable type inference introduced in JDK 10, but it was added to lambdas within 11. So we had some fun with this one. Everybody remember the rhyme var var new var? Or is it jar 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 binks? Something different genre there, but a lot of things going on each line here. Var Dr. Lester. Oh, and then Dr. Lester's another var. A var reliance mistake. Var numbers. There's just too many vars. Somebody else would probably say use appropriate variable names. Anyways, we've gone through that, and we have our 4 system out. Where do you think this is going to end up at? Oh yeah, don't forget that private interface down at the bottom.
Good point.
As always, chat out your answer. You have a 25% chance of winning, which is a higher probability than the Powerball or Mega Millions lottery.
That's it.
Yeah, those are almost $1 billion. Okay, so people are still thinking on this one. Now we have a first one, D. All right. Let's see if that breaks the ice for everybody, or should we have Duke fly around? Okay, Duke's coming. Where is he going to land? Oh, he's a little spastic there. B, what's going on? Okay, so let's go ahead and dissect this a little bit. You can see in the first yellow box there that var can be used as a name also. It's not recommended. But also, if you're going to use var as a name and you want to set it to null, you have to cast it to something. In this case, we just cast it to the interface var. Works out fine. Reliance mistake. Okay, here we are using the Lambda var modifier, so we can actually put final in there, which was new to JDK 11. Our next one is a more interesting one, casting type. Var numbers remove. So, as you know, when a var is used, the compiler will type it as what's on the right. And so in this case, it's arrayless numbers. Arrayless is under the collections as a hierarchy. So collections and list have different implementations of the remove method, and this is the kind of the intriguing aspect of this one. So when we take a look at the output there, yeah, we get var collide, Kirk and Spock come up, and then we get the Khan and the Borg with Darth Vader again. And then we get our Dr. Lester class name. It's the inner class, so it's going to come up with the var. And then print the numbers. The numbers remove the integer value of, which is an object. So as opposed to removing an index of 1, we're removing the object 1, which happens to be in the third slot, second position, index 2. So that's why we get the array as 3.2. Interesting stuff there. Okay, let's take a look at our next couple of locations here. Whoop, JDK 12. But it also got destroyed. Got moved to 14. 13. Where's planet 13? It's not there.
Oh no.
It just disappeared. So now we ended up on 14. It's another short term. We have to wait till 17 to get our next long term, but let's take a look at this next challenge.
Okay. I'm gonna give a brief of this challenge. So as you can see, we are invoking the getVulcanSurvivors method, and we are passing an enum that we created on the bottom, the Star Trek characters. And on each getVulcanSurvivors invocation, we are sending one enum, and then we are going to execute the correspondent case statement according to the enum. Okay? There is some logic involved there happening, and I'm going to give you some time to think about this challenge, and let's see the alternatives.
Pressure's on for rescuing the survivors. We did have a comment from the last one with Vincat. And yes, Vincat. Very good presenter. It is true. But focus on this problem. Where are we?
Yes. Where are the answers, guys? Any guess?
Let's see. We look at this one. Oh, we have an A. Yay. Thank you, Gene.
Okay. We have an A. Who else? C.
Okay.
Who else?
One more. We have 2 more answers.
Okay, we've got enough.
All right, let's move on. What's Duke say?
Da-na-na-na.
Okay.
Oh, it's B. Okay. So let's see why then. So at the first method invocation, we are passing Spock, which is going through the first case statement. And then we're going to simply print every day is a rescue day. And then on the second method invocation, we are passing Michael Addington. That is falling into the second case statement. And this is very, very tricky. This line is very tricky. So the value of method returns an integer wrapper type, which is out of the cache. So the cache from the integer wrapper is from minus 127 to 128, but 129 is out of the cache, right? Therefore, well, we're going to compare the 129 number with the 129 integer primitive type. So when we do that, then the wrapper type will be converted to a primitive type, which will be, in the end, true. Then we're going to print the number 10, all right? So this is very tricky. This is very, this is a very hard one. And then we are using yield. So you can realize that when there are more than one line, we can use the yield reserved word, which enables us to not have to use the break word as it was before. When we were using the switch case before, we would have to put the break keyword on the to stop execution, right? And then on the case Michael Addington, we are comparing a string 6. Well, we have this in when we put the number 6 there in the string, we are creating one string in the string pool. But when we use the new keyword, we are forcing an object creation in the memory heap from Java. And what happens is that when we use equals equals, we are comparing the reference, and the reference are different, right? So therefore, we're going to return 4, the number 4. Another interesting thing about this second statement is that we are using lambdas, and we are simply returning the value. We don't need to use the yield because we have just one line there, right? And then on the default statement, so when we invoke the alien Garrick, then we're going to return the illegal state exception, which will print illegal state exception with no survivors. So why the new switch case is good? It's because we can create cleaner code and avoid the boilerplate code, okay? So that's it about this challenge.
Yeah, very good. And the new switch expressions were introduced in 12, second preview 13, and now our final in 14. So let us move on to another interesting one, which is first preview in JDK 14, records. So take a look at this little guy here, and we have our commander record, taking a ship name.
Before you get too far, there's a question about the previous slide.
Someone
wants to know about toString.
Okay, thank you, Gene.
Okay, so basically we are returning the illegal state exception, but we're not throwing it exactly. We are just returning the object, illegal state exception, and then we are just printing the toString method, the toString on the last system print ln. So as you can see, we are returning survivors with lim, which we are printing the toString method. So we're not throwing it exactly. We are just printing the object.
Right. So I think the main thing here is that we're creating the object within the Lambda, and it's not being thrown. Okay.
Yeah.
Okay, and then to answer that other question about records, that second preview is in JDK 15, so it's still not final. So it will be blown away and put into JDK, I don't know, 16, maybe in some future presentation. All right, so getting our tissue computers, compiling this guy here. We got our main method, which is going to create a new commander. We got a new record ship, new ship. Printing out the commander name, and is the commander equal to another new commander? Let's take a look at our choices here. Oh, look at that. We just have 4x2. The fingers are crossed, yes. Uh-oh. But they're not all. It's interesting. A, B, C, or D. What could it be? Good thing there's only Spock and Worf in this one, right? Yes. Hopefully, maybe we have some trekkers in the audience. They aren't going too far with our genre mix-up. Yes. Okay, don't hesitate to throw a letter into the chat. There we got some C's. Okay, look at that. Spock and runtime accession. What does Duke say? A room and C.
Congratulations.
Yeah, all right. So what do we got going up on top there? We've got record with a generic type, T-ship. We're using the compact form, the conical constructor commander there. And then really what it comes down to, line 9, where we're creating this new ship record. And it's not serializable in this instance. So of course, line 4.5 will throw that a runtime exception. So our commander, yeah, the line 8 and line 10 is Spock. Very well done. All right, let's move on to another challenge of 14.
Okay, so this is the instance of pattern matching challenge, and we are invoking the shoot method a couple of times. And we are using the pattern matching feature from the JDK 14. And we are also using the old way to use the instance of operation. Okay, so I'm gonna give you some time to think about this challenge, and let's see the alternatives.
So one thing to note, I just see it here, is that there's a funny double quote on line 10. Don't worry about that. That's not a part of the challenge. Yeah. So formatting is not what these slides are about. The code on GitHub does work. And yes, this is the first preview of pattern matching. Second preview is in JDK 15. This is from a fight scene. The music.
It has to be a challenge.
Yes. All right.
All right.
So, got some. There we go. We got one coming in.
Okay, we have one answer. We have A. Who else is gonna risk yourself?
Step up to the challenge.
Step up to the challenge, yeah.
Yes. So bonus points for anybody who knows the theme music that we're playing here. Okay, ready for Duke?
Okay, let's see the answer. Da-na-na-na. Come on, Duke.
Oh,
Ooh, it's D.
D. Where'd that come from?
Oh my God, why it's D? Okay, so at the first method invocation, we are using the letter L. I know this is very tricky, but actually we are making the integer number into a long number, which means that it's gonna return false in the second if. So on this first method invocation, we are passing a string. A string is not a string buffer, but a string is a comparable, right? So it's gonna fall into the second else if, and then we're gonna compare if this string is equals 11 type 1 phaser, which is false, right? Okay, so the first if is done. Now let's go to the second one. So in the second method invocation, we're passing true, which will be autoboxed to object. And the Boolean wrapper type is also a comparable. So true is different than 11 type 1 phaser, which means that's going to be false again. Perfect. In the third method invocation, we are invoking a string buffer, but the string buffer is invoking to string, right? Therefore, it's not a string buffer, but it is also a comparable. So Plasma Canyon is not a type 1 phaser, which will return false again. And in the last method invocation, we are passing runtime exception, which will invoke the last instance of serializable. And then we're going to print the runtime exception disruptor serializable. Serializable. Some important points of this challenge is that in the first if, we are using the old instance of operation. And on the two last else if, we are using the pattern matching. We are using the pattern matching instance of, which means that, yes, this is the new syntax. Yes, Rosa. So we can simply declare a variable on the comparable, and then we don't need to do the casting, which makes the code cleaner and we avoid some boilerplate code. Okay, so this is it.
Yes, and that long in line 3 might be hard for everybody to see that one, but let's move on to the next JDK 15. Look at this. We're coming towards the end of our travels. Text blocks, and these are now final in JDK 15. So let's take a look at this one. We've got a couple of methods. Look at that, Jedi without text block and Jedi with text block. We're not in the Star Trek universe, Rafael. What's going on? We're in a time warp. The space-time continuum is fluxing here, but you can see, where the text blocks is the triple quotes. So we'll just call that out. And we got a couple of print statements in here, equals and formatted. So let's go ahead and take a look at our solution set. So now here we have a true binary choice system. So true, 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 false, false, true, and false, false. Look at that. Well, let's see. Everyone in our audience can take a look at this one. Hopefully, it's an interesting one. Yes, you must parse the code, compile it, and then run it. It might be interesting to also ask the audience if they use text blocks before. Okay, so we're getting some answers in. Looks like A is leading the pack. We have a B.
Okay, we have A, we have B.
All right.
We have another A.
Okay, let's see what Duke flies around to. Where's he going? Where's he going? C. No. What's going on here? Oh, take a look at this. Line 7. Method precedence. Okay, let's dissect that. We've got in line 3, 4, 5, and 6, we're concatenating strings. Well, the plus operation has a lower precedence than the dot operation. So we're actually going to strip HTML and format it with Luke. So we're not going to get the string you thought you were going to get. Whereas in the text block, we are stripping the entire text block and formatting with Luke. So as the box number 2 with the arrow going down to the formatted is concatenation completed and the substitution succeeds. So yeah, the first go around without text block does not equals with text block. But when we do the substitution, it does. All righty, very interesting one, and that was finalized in JDK 15. Let's take a look at another one from 15.
Okay, so we have here on the sealed class challenge a sealed interface captain, which is permitting Spock, Sarah, and Janeway. And then we have a static non-sealed class. We have another static class and a record. And then in the main method, we have some polymorphism operations and anonymous inner class invocation. And pay attention that we have sharp A, sharp B, and sharp C, which represents each line. Okay, so it's going to be important for you when you choose your alternative. Okay, so let's see the alternatives, and I'm going to give you some time to think about the answer.
Yes. And we're not talking about new languages, sharp A, sharp B, sharp C, like C sharp. No,
Yeah,
no.
that's it. We're not talking about C# in a Java conference. No way.
Yes. A very interesting conundrum here. Sealed classes. So, and this is their first preview. So it should be interesting to see how it goes with the second preview, if they make changes or keep it as is. All right. Trivia question. Captain Saru. What Star Trek show? What Star Trek series is Captain Saru on? What do you think, Rafael? Give him a little more time.
Let's see if we have, okay, we have A. Okay, more answers, more guesses. Who want to risk yourself? Okay, B.
B.
We have 2 A's, we have 1 B.
Okay.
Who else? Okay, we have 3 A's and 1 B.
Okay, ready for Duke?
Ready for Duke. Come on, Duke.
Show us the way, Duke.
Ooh, okay.
C. All right, what's going on here?
Okay, so let's see why it's C. So as you can see, we are using a sealed class, sealed interface captain, which is permitting Spock, Saru, and Janeway. But on the static class Janeway, we are not implementing the captain interface, which means that in the hash A, we're going to have a compilation error because the purpose of a sealed class is to define which class has to extend the sealed class or the sealed interface. On this case, Janeway is not implementing the captain interface, which will cause a compilation error in the sealed interface, right? And also, when we use sealed classes or sealed interfaces, we can't use anonymous unit classes, which is happening on the sharp C. So we have a compilation error on the sharp A and on the sharp C. And what is the purpose of the sealed classes on Java 15? So the purpose is simple, is for your system design. So for example, if you have a logistics system and you have a vehicle class, and you want this vehicle class to be extended only by truck and car, then you define that on your class, on your sealed class. And then we have more control. So if someone else adds some other vehicle class that wants to extend your vehicle class, it won't work, right? So using sealed class gives you more control on your system design. So that's why it's useful to use sealed class. Okay. So this is it.
Yeah, so yeah, the sealed classes introduce first preview JDK 15 and gives you a lot more control. Let us go ahead and review the mission summary as before. We went through quite a few JDKs here with implementations of interesting aspects. And of course, the history of like when Switch was introduced and text blocks were introduced. So all kinds of good things. So here again, you can reach out to us on our Twitter or anywhere else in the world if you like. And ready for the last slide, Rafael?
Yes, let's go.
All right.
Okay, so I'm also giving away the Challenger Developer Guidebook, which has some strategies for you to master Java techniques and also technologies that you need in the market. So it's about calibrating your mindset to have massive success as a software engineer. So don't miss out this chance. Go to the link or get the QR code and get your book for free.
All right. Thank you, everybody, for participating in this session with us today. We hope the rest of your day and the rest of your sessions that you attend are wonderful. Please leave comments of how you liked all this stuff. And we hope to see you all next time. We'll be hanging out here for a few more minutes if Gene allows us, if you guys have any other questions.
I think people have been asking questions on the slides, but you're right, we might have some straggler questions. Also, before everyone goes, next up in the conference is the Diabolical Developer at the top of the hour, and I've included the YouTube link in the chat to make it really easy for you.
Diabolical Developer. Sounds like an add-on here. Okay, thank you very much.
Thanks a lot. It's an honor to be here.
So I saw somebody comment that they were over in Europe, so it's a nice lazy afternoon for them there. Yes.
Yeah, so
It doesn't look like we have any questions, so I'm going to end the broadcast. Thanks.
Okay.
Okay, thanks a lot, guys.
Thank you all. Have a great day. Bye.